Thank you very much for being here, and I'd like to thank Rooted for this opportunity and a happy 10th anniversary. And we're going to comment on scale threats detection, which I've been working on for the last years with different tools. One of the tools I've developed is what I have deployed in certain environments, corporate environments, and also what I'll still use is osquery. And after this introduction, and you know that detection, security and safety engineering, free source, open source, this is what I prefer. I always work with companies, a big scale. Now I'm working with big mechs. So let's move forward. The first part of my presentation, it is precisely, I've divided my presentation into 3 parts. First part is precisely the osquery. What is osquery? The way it works, the case where we can use it, configure this, and some aspects, some advices to start using this. And then after this, I'm going to try to explain the concept of the osquery client, the servers, and the network nodes where we will have directional communication issues. We will start in the second part regarding the servers, the configuration aspects, and we'll try to explain concepts, consultations, programmed queries, and packs, and how the queries will play a role regarding the yield, regarding what we achieve with this, because it's very important to have the minimum fingerprint without the system and to enhance the results. And the second part of the lecture will be, the second part of the conference will be to use the remote API, which is a concept we use, and details related to configuration. We can use flags and also basic commands on osquery, like on-demand queries and almost real-time queries, file carving, and then we will have a demonstration on a TLS endpoint we're using for the last few years. To start with, I'd like to mention, how many of you have already heard the operating system, the operating system query, osquery? How many of you have used this operating system? Well, not many. Well, we'll see. osquery is a tool. It's a tool that it's adding a layer to the operating system where you could carve information using SQL. It's been developed and it's been open source since 2014, end of 2014, and Facebook was a company developing this, and I had the opportunity of starting working on that from the very beginning, so we know how it works, osquery, internally, and there were critical parts also, but the truth is that it is important to know the tool and to analyze the instructions with a tool you know well. It was born with the idea that we would follow the example of instrumentation, host instrumentation systems, and one of the characteristics of osquery is that they use the API 100% from operating systems. No forks of exec, v, no calls to system, no. It is directly, the information is retrieved directly from the operating system. And here we have in the web of osquery as we see here, IO, and then we have all the information on this, and even on Facebook. You have the different approaches, different branches, where you can see how it has evolved. And then I have, for 5 years, worked in California, and I have contacts with companies that are really important in the field of technology. What I would like to do here is to demonstrate which companies are using osquery. It was developed by Facebook. Facebook deployed this at a huge scale, osquery, and then afterward, knowing that it was a tool that has a good performance and that it did work well for the case of use that was necessary, Other many companies followed the example, and now it is almost the default agent for cooperative systems, and productive systems, like in Netflix and many of those you see here. Netflix, Uber, Dropbox, B&B, they do not want to acknowledge they use osquery. But why do we use osquery? The motivation for creating osquery, as we see here, there were very many administration systems, scripts, where they were able to execute several commands on cooperative hosts. And there was no standardization. Let's see how I can retrieve the information, specific information, for all the fleet, all the devices, all the production system, with questions like I'm going to ask you. Let's imagine, for instance, how could we know which cooperative hosts will have the extension with a certain ID added? How many of you would be able to say how many file descriptors were open yesterday per hour in all your production systems yesterday? And another question could be which devices are routing the virtual private networks towards the local area network. So those questions that are not the same, because each one will deal with a different part of system administration. What they wanted was introducing tools to, in a very uniform way, the same way, using this everywhere for developing purposes, for production purposes, for corporate management purposes. And the decision of using osquery everywhere, and the language SQL, well, the abstraction was SQL. Basically, is that the concept of osquery are universal concepts depending on the basic concepts of the platform on which you're working. And this is a tool, it's a concept that's been there for years, for many years. And then it is true that it's quite popular. Developers, system administrators are using it. So it's easy to invite people to use it, to encourage people to use it, using SQL language. So we have, for instance, questions where you get the PID, the name, and the user ID from all processes. And then, for instance, another item added here on why have we started using SQL language for that. Basically, we have an operating system where we have several parts, and then that is a concept out of which you would like to extract information. The concept will be the table you're going to use. Once you have the concept, you say, I'm going to focus on that part of the operating system. How about the details of a concept about which I would like to, on which I'd like to concentrate? The columns I'd like to extract, and then afterwards I'd like to apply restrictions, not to have too many data, or not to or to look for the information I'm interested only in. So, for instance, you would like to retrieve all processes that won't have the user ID equals 0. That's a restriction. Or it could be used in more advanced mode, for instance, SQL, joining this with other table you have on the system. In this case, you join users and processes where they have the ID of a user that's given here, and those are interesting uses of that. Once having done this small introduction on osquery, the approach, the philosophical approach, we have here the first part, which is the command line interface, and osquery I. osquery is the client on which you can execute local queries and see for results. This is what you see. In the case of tables, they use osql elite as a motor, and they have what was developed by Facebook also, which was relevant at a given point in time. Now they are having doubts about using it or not, but the performance is rather good. And the process is that you have osquery on your machine, and you would like to know which tables you should use, the queries you'd like to deploy. And once you know your strategy well, you define consultations, and then you use osquery. I'd like to invite you to go to the information. You have a link on the slides. It's on the repository, and then it is well documented, well explained, all the different components of osquery and the command line interface and all the command lines. I forgot about command lines. We should have talked about command lines. Anyway, we have here the command line, and you have like self-completing tables and so on. So once you are there with .help, you retrieve options, possible options that are useful, and you have from the you can have, for instance, all and the name of a table. With the .all, you select all from a table, all elements from a table. For instance, you could change format of the output. You could use whatever format instead of columns. You can have rows instead of columns. Anyway, have criteria. There are different parameters you could directly put in the command line to retrieve what you want. And then I'm going to focus on the .tables. .tables is the command that you're going to use in osquery to know all tables active and on the platform on which you are executing things. You will see here tables that are really active, tables valid to have concentrations on. You won't see other tables. If you would be on Mac, you wouldn't see tables that are valid for Windows or for Linux and so on and so forth. This is useful. You say, I'm going to work on this, and then it's okay. And then to know in detail, for instance, you have here the command in general used is what you have here, and pragma table info, and then if it is a foreign key, whatever, then you add details that are more specific about the use, basic use or advanced use of the search engine you would like to use. Here in the release, we have 229 tables in the 3.3.2 release. We can support 4 platforms: Mac, Windows, Linux, and FreeBSD. And those are data that are easy to retrieve and correlate. And in principle, with the osquery IO and the thing, you can see different tables according to release. You can choose according to the platform, according to the architecture, and to know what each table means. This is a past, and if you want to look at the code, you can also get the code. Here simply, I'd like to give you an example on the number of tables you can have here. For instance, .tables, ACPI tables, and you see the tables you are interested on, the one that are most, those ones that are most useful. You can jump from one table to another, and so on and so forth. One of the important details to understand osquery is that the execution per table, at a given moment you have a select, the execution is taking place at that very moment. When you have the advanced configuration of osquery, there are certain tables where you have cache. They have a cache that is according to a template. Those are based on the lower frequency of consultation. That is more complicated, but I just mentioned this. It's like information dropping for you to know that there are certain tables where you have this templated cache memory. You have then the possibility, when you retrieve the table, you see there are differences, and then on what had been executed. There is a code associated to the operating system, and this has been executed every certain time, period of time. What happens when you have a higher load within the operating system? You have to imagine that the execution frequency is lower, then you might have peaks of using the CPU, so higher load on the CPU. Once you have the tables, we have a select all. For instance, you can retrieve all columns or some of them, and you can define what we called before the strength. In this case, we can have a file table. You can define the root on which you'd like to ask something, and you get the directory of a given root. And within the operating system, you look for the root, and you retrieve this. A join example that's useful is having a join hash using the path. And then what is the hashing function you'd like to execute in the case of that given file? You see there are lots of possibilities, and I'm getting the MD5 here. So if we use all those are parameter tables, so we see the load on CPU varies, so we'll have the impact on performance, and I'm going to give you some useful information. We have some basic table examples here. For instance, we have easy to correlate data, easy to retrieve data from the different systems according to what has been installed, the kernel modules that are, for instance, running what's been executing at a given time. So, some example: what is the host name of the system, and how many users and which users do we have on the system? Which processes are running now? Which is the host of the system? Well, the step will be then easy, as you see here. We should see it. I would have a client here of osquery, and it's what I mentioned before. If you have OS, do you see it? Because interpreters cannot see anything. Anyway, osquery I, if you do not launch this as a root, the columns will be empty. You need the permit, you need to have this idea. And what about this? Well, here you have the format, which is a scheme of a table I'd like to consult. And in this case, this is a command I've mentioned before, pragma table info. I'd like to know about the host. And then I have here, we have a host name column. I select host name from system info. Host name from system info. And you've retrieved the host. And that is the steps to follow when you're not an expert regarding the different parts. And here, this will be to extract the host of a system, host name of a system. In the case of users, you select UID, username from users. Those are easy tables to use to retrieve useful information, and very easy to conduct queries. More complicated is, what about the user and the shell of each process running? So tell us the user and the shell per process running. You select PID, PName, PPath, username, and the shell from processes. And you take this, you have a join to the users table, and you have here the information that you want to see. That's an example. I'm going to show this to you, the same query, and then you will have here the users running, the PID, the user, and the shell per user. And that's quite convenient to know that it is a problem of a user been created for a backdoor entry or something wrong. So then, how about it? And once we know the concept, then we have here this. At the level of services, how we're going to deploy osquery when I am not going to look directly at things. I want to deploy OS query, and I have to program consultations, and I want to retrieve blocks. The daemon OS query D is very important, the binary, and with this type of daemon, we have differences regarding the way it's been executed. And we have here this daemon's been prepared to launch it. We have here whatever init system MD, launch D, service windows, whatever. We can execute programmed queries in all machines you want to monitor, and you have logs of the state of the daemon and results at basic level. Options of configuration are very many, and you have to see the well, it is you could use the help to look at the flash to see all the options that you could use. Here, I'm not going to mention the daemon or whatever thing, configuration file, and then this has been defined and it's explained in help. So basically, the scheme used now, when we put this together at the bottom here, you see the operating system, the users, the services. So first, on top of this, we have the OS query ID, a configuration on which we conduct logging tasks, and with a centralized management, we update, or we can get the logs. And once we get the information, it's when we start with a strategy to have incident responses and very many use cases. And then the flag for initiating or initializing the configuration. In the case of the US daemon, the most important is to use flags, commands, parameters you put into the daemon. But to render your life easier, you could use flag file, and in flag file you have everything. So all the parameters. One of the user cases that are frequently seen is to use what you see here, one type of IT or normal software, and they create the software, the flag, and depending on the access and the system, and then the daemon starts with the configuration that you've chosen. The help is extremely useful here for SQRI ID or the OS query ID. That's very important. You should use help. Once we have US query configured, flags here are just injecting configurations inside the daemon. We can use this with a configuration file where we were going to define several paths, and it is important to explain the different parts of this configuration file. The first part is the field of option. This is a JSON file, standard JSON file per block here. In options, we have the same values and what you receive. For instance, you could launch the servers in a way. You could configure this with a plugin file system, and then we could override the things, and that's something that could be done. Other important thing in the configuration file is when we talk about decorators. Decorators, imagine with all results we have, with OS query, the queries we have programmed. I want to add on top of this, I want to add some metadata to retrieve more information from those machines, and I use decorators for that. Decorators, you can have only one daemon load, or whenever you have loads into the centralized system, and the detail of decorators, the thing of decorators is that you might have an undefined number of columns dependently on the table you're making a consultation on, but only one result could be accepted. If not, well, there are cases when you have no result, because that is not that you would like to overload the system. You won't like to overload the system. It's like adding metadata. Adding metadata that are basically useful to retrieve information, to have a more complete information on what's happening at the level of each system.
The program of queries that I was talking about are the queries that you were looking for at customers' queries, and there's a number of fields within the configuration setup JSON, where you can define different things. For example, your query. The query is the chain that you will be executing as query. Interval is the frequency of execution seconds. By default, you have a possibility of adding details. So you have all the queries executed every 60 seconds in order to avoid loading of queries. You will have 5% margin in the seconds interval that assign different queries at different moments for them not to be executed at the same time. Platform. Also, you might have different kind of systems, and the Windows queries are not the Linux queries or Mac queries, which are not compatible with the others. So you can limit the number of queries executed in order to avoid overloading of the daemon engine. And there's another action, the sharding action, meaning this query will be executed, only this one. So I use statistics to know how many times this query will be executed, which is a little bit artificial, but we can do that. And then snapshot. When I program queries, a lot of people say, I don't see them, I don't see the result. This might happen because when you select any kind of table, you flag the buffer that is maintained by your OS query for results. And when you have program results, you will see the changes in these results. But if you activate snapshot flag, you will see all the results, which will provide you with more data than expected with the system you use to manage logs. So it is important. For some cases, for specific cases, it is important because if I want to see all the processes that are being run in this machine every 30 seconds, you might believe this machine has been compromised, so you don't want to use audit system or sales tables. So you say, okay, every 30 seconds. What happens with this? If some malware is executed in the moment in which you're not running the query, you will not be able to see that. And I don't know what would happen. Like I said before, scheduled queries. So you have the schedule with the query. So you would define the name with all the fields I was mentioning before. And then you have query packs, which basically means I have my setup, which is okay. Then I have something that applies to everything. But then some queries are for specific things that can be activated or deactivated, or they might be running in one machine and not in the other machine because it will be very big. So how can I aggregate different queries in any kind of file or in a specific logical group? So you would be using query packs with different fields that could be applied in these packs. Query to be executed, the interval version from which the query is executed. Imagine you have a table that creates only GIFs with the 2.0 version, and you have a 1.8 version. So in order to avoid creating one more line, you can say, execute this query in the machines that have only up to this version running. So then description. This field is an idea that was implemented to encourage people to share query packs or compromise packs to define the query you are running and to indicate the value as well, which is also of the fields. So osquery.com for packs that have been tested by the audit team of osquery. So some for monitors, some for responses in the event of incidents, for IT compliance, for Windows or OS X. So I invite you to go through the packs for you to know the kind of filters you can use for the different queries. And let me give you an example. For example, for you to see how a query is in a query pack. So you define the field of the query, the name of the query, and all the other fields. For example, I didn't include value and description because this is very simple query, but you might add them. Now, so we have the queries at a local level with their name, with their title. So we execute them in our machine. We say this is going okay. These are the tables to be executed. Fields are clear. I know what the system is. I know what the columns I want to query about. So if I want to join, you validate, you evaluate your group of machines, and you say, oh, these queries will be executing at this interval every 24 hours, for example. And you say, I'm going to launch this for all the machines to see what happens. So now imagine, for any event that happened, one of the machines you suspected was compromised, and you want to get all the bases in one directory, but the problem is that you launched all this to all the production system. But I want to see this specific machine with big directory with smaller directives. But you can have a CPU that is small, and you interpret that this machine has a problem, etc. So the impact could be on production system or products that are being developed at the company, or this might entail problems in your employee's computer. So we have an internal application, osquery Watchdog, that could be applied to all the daemons. So things are done by default in osquery, and the reason why this is done like that, I mean, applying this by default is in order to have stability of the systems, and because that has been tested. So osquery D is executed in a single thread. So if there is hoarding of the service of the CPU, this explains the problem. So the osquery D watchdog does as follows. So if the use of the CPUs is of more than 60% for 9 seconds or plus, osquery will be reinitiated. Same thing for the amount of memory using. If the machine is using more than 200 megabytes of memory, the service will be reinitiated. If this value has been touched because you believe that that you need more margin in order to use osquery, you will see that your nodes will be reinitiated and the osquery service. So this might lead you to think, what is going on here? But the thing is that the osquery D watchdog is responsible for that. So we have a computer, and I want to execute this. These queries, I want to launch them for all the machines with this interval, etc. And I want to provide this service. So I have clear in mind what is the setup I'm going to implement. What is the next step, therefore, to be able to monitor or manage all your osquery nodes from a centralized system, meaning how do you go from an osquery system to a botnet? So you would use the remote API of osquery D, and you have some product options offering you this solution. Some of them are open, are for free. For others, you have to pay. Some versions are in the two places because they have an open source part, and then they have a paying version. For Collide and Central is what they have. So they have a free version, and then they have a more complicated version that you have to pay for. The flags that you will be using for the osquery daemons to set them up in order to use centralized server are listed here, and you can see them on the screen. These are the plugins that we'll be using. So client certificate, if you want your nodes to open with a server using mutual TLS, so you would define the key. You define the host in which they will be speaking each other, because the TLS, the shared TLS, is on the internet. So there's no need of VPN or any kind of access. It would all depend on your production system. And so you will see what is the host you will be using. So you have the mutual TLS, but then the PME certificate, etc. Well, these are the flaps that you will be using. What is the architecture scheme that is basic? Is as follows. You have a TLS connected to the internet. Okay, I'm going to show you using this. It's going to be easier. Okay. So you have all your nodes using osquery as customer. You want this to hack them to send results and logs. You send the information through the internet with a TLS endpoint, and I put a lock here because osquery use TLS for communication to avoid cases where I can see communications from a machine, but at the same time I can see sensitive information. So this is only possible on TLS. So the basis to develop a basic TLS endpoint, 4 main parts. First of all, you define the endpoint where you would define the end role and you launch post, then another endpoint to receive logs, status or queries result, another post petition for nodes for setup of configuration, and another post for extras, on-demand queries, file carving, or if another function is launched using the osquery. The documentation, the configuration defines the petitions, the requests, the format you have to send and receive, and things are very easy. And it is true that this could be implemented by using script with a simple past, or maybe you can have a system that doesn't support queries, legacy type machines, etc. So you could implement the API, the remote API used by osquery, and have another system that supports this kind of ports. That could be possible. Let me focus on extras now, because I want to explain on-demand queries or real-time endpoints. So you have the osquery daemon that is implemented as service in the machine that have a program or configured queries to be executed at each time length. So I need to investigate, to search this kind of machine and this host concretely, and I want to know what is the information of the operating systems and the users or the routes or paths that are being used, and I need this right now. So you could implement this part, TLS endpoint, configured queries, and this is important for research, investigation, and in case of incident response when you need first-hand and very fast information. Flags are as follows. You set up queries to activate distributed queries, which is deactivated by default. You would define the intervals in which the query will be checking in the host that is running your TLS endpoint. You define the plugin that is working, the TLS plugin actually, because in osquery you can define different plugins and you can make them run at the same time. For example, you say, I want osquery configuration and on-demand query will go through TLS, but logs will be done locally, because I use Logstash or Plans Forwarder or any other kind of solution. These logs will be locally stored, and then you send them to a different system. So you have the flexibility, the necessary flexibility to define things according to your needs. And this would be defined here. So you would define the maximum number of attempts to send the query, and then the path of the system for either read endpoint when you launch a query, a read endpoint, and then you get the results and on write. So you have read endpoint and write endpoint when you receive the results. So another part, another extra configuration is file carving. So file carving is when you have a machine and you believe this machine to be compromised and you want to carve all the files in home/user/ percentage, and you want to take them and send them to your TLS server. So you define one file, a single file, or a number of files using logs. For example, all files in this directory, or all files with this name, percentage, Mr. X, and then percentage, because the like effect of the TLS would be considered in this regard. And you can activate compression. Osquery automatically would bundle them together and then send to TLS for communication to be faster. The example of the queries sent to Osquery is as follows. You use the carves table, you define the file path, file or directory, and you should put path equal 1, otherwise carve will never be run. So flags, the real-time query system is activated by default. So this is an experimental function, so you have to activate 2 times because it's deactivated by default, I'm sorry. So you have the carver, and you will get the size of the file you will be receiving, the number of blocks for each request of the continue endpoint, and then the number of files could be configured. So first, request saying I'm going to send you all this, and then files will be arriving. So you order them. Once you've received them, you put them together, and then you verify the path. So I developed myself a solution for TLS endpoint. This is the architecture I use. So basically, the idea is that the TLS endpoint is on the internet. System could be deployed all around the world. You have all the osquery nodes, results, etc. Or logs. This is very simple. So then you will have the administration part for queries, or the system used by operators, or the responses team, and then the administration will be done through a database. So basically, this is a very simple distributed system which works very well when you have all the osquery nodes. Different components. The TLS endpoint first. For the osquery nodes, no authentication. You can use simple certification or authentication by certificate, and then different contexts for execution, and the data are sent directly to the system. So that is the original design was designed to be used proportionally, because at the beginning you try to roll down one solution at the beginning, and I fought with the IT team because one Monday morning I came to the office and 15,000 machines had been integrated into that. I had developed this for this to be distributed in 10 instances in different geographies, because it has been thought for being used as in a simple way. So you say something is going to be screwed up, I'm sure about that, but you have a great traffic running through this, so it has been thought for being used in distributed system in different areas. So the administration console that communicates with the TLS through a database, it could be not on the internet, but on a private network or a VPN, or you can use different sign-in nodes, etc. And then maybe because I had a mad experience, I create myself a commands control database. So this is the line of command so that I don't miss anything. So this is good to automate tasks because nodes are given in different formats. And now the most important thing, which is the demo. Okay, we log in. So this is the system, which is very simple, as you can see. I don't know if people sitting at the rear can see this well, but we aggregated here the service aggregated or added. When you roll down things, you add the service, the administration or TLS service, because the two of them are working with the same machine, so they add themselves, and you can monitor the system through the two of them. So you collect information, you set what the execution process will be, the machine, the local host, you see the changes that were produced, the kind of platform, the version, you have also the IP. And if you have machines using the internet, you can use geolocalization features and more details when the enrolling was done, when the last status with the results was produced. So data that are interesting to manage different machines. So status is a little bit complicated, but it can be good to see everything. And then results. And these are the new per context. So this is the setup or configuration, as I said before, the different options, the schedule queries, the operators, and metadata that aggregates information that is necessary for the service, the queries that have been programmed or scheduled. And now I'm going to show you something with the line of commands, using the line of commands in order to aggregate a new function system, and I'm going to add new things. Why is that? Because I think it all depends on the share or pepper system to add all the machines. So I create myself a system with a script to configure or add osquery within the endpoint I'm using. So I have a couple of virtual machines that are working, in operation now. So OPT, control, the different options. So the first thing is to add a context. And you say, okay, you write context, ADD. We need a context. We add H. And then router minus host 10.10.10.6 minus conf slash a background machine, then query LOI query. So I'm writing here the distribution to all machines. Same thing that I have, the same I have in the development context, and then the certificate according to which that I'm going to be using for the machines to recognize the system. Otherwise, our query will say, I cannot validate the system, and I'm not going to use the system if we don't include this. So I have added everything. So we have the router context, the D context. So going back here, we refresh. We see the router context has been added, machines that are activated not in operation. So I enroll machines. This is standard for Mac and Linux, all the Unix machines, and this is PowerShell for the other systems. And I have here the machines, so I execute them here. And so you have the enrolled thing. I executed here and here. So we didn't have any activated machine. We have 3 hosts here, and you can add more instances that are running if you want. So you say, I want to know all the processes that are running in all my router execution environment. So you execute router. When you execute query, it's a Linux machine, so what do I need? So I need this, so I see here all the processes. When I get the process, I get to the last process added. So you add the query here, and now the target I want to execute, so I'll be using per context. I want to use all the machine of the context. I launch the query is working. The number of successful executions and failed execution based on their status. As we can see, 3 machines in the router execution context. So I would go to query, and then these are results with all the systems based on their name and all the queries running in the router execution environment. So you could use plan, alert to apply other rules, etc. Okay. Now a couple of things that I need to complete implementation still. Probably this tool will be opened. I'm very obsessed, so I don't want to open things if they're not completed. So I would use a modular logger for ELK, Kinesis, Kafka, and other kind of modular systems. I want to use this to be able to, with WSS, but at the moment we do this locally. I want to finish implementing caches with Redis. So by using one cache, you would avoid some problems when you use Redis. So osquery, advanced osquery, if you're interested, you might find this on your own, because this will change your idea of how coming up with responses in an efficient way. So you might find FIM, file integrity monitoring, because osquery could be used to detect file integrity breaches. So event tables or audit system that generates information when things happen. This is good to know when new processes happen or new connections happen, or when new users happen, and that's very good. So the osquery extension to be executed as part of osquery with a system C++ Go or Python. There is an extension repository done by people of Jello-Bits, which will allow you to create firewall rules and activation for the platform you'll be using osquery, which is an advanced query, because you can orchestrate things and say, if I have results from this query, you will create a rule for this machine to be isolated and see what is happening with the machine to know whether the machine was comprised or not. And then automated table construction, ATC, that defines the information you're looking for, and osquery automatically will create a custom table. So with real-time queries or scheduled queries, you can query the custom table. Otherwise, you would have a more complex or complicated query, which will be longer. That's it. Query has a lot of information. You have the codes on the website. You have an official osquery flag. I don't know if you have time for questions or not. Oh, yeah, we do. So questions. Let's see if I made up everything okay or not. No questions? So if all is clear, it's maybe everything was clear or nobody understood anything. I don't know. So if you have questions, oh yes, there's a question here. I think it was very interesting, your solution to monitor obscure things. Is there an integration for file monitoring? I'm really interested on that content. No, hashing files in order to have files, and when the file is changed, you you see an alert. On the other hand, monitoring services that might be listening to incoming connections to know if something has been injected or not.
Those two questions are very interesting. For the first one, you have to look at the system, file integrity monitoring system, because it is exactly that what's done by the file integrity monitoring system, monitoring all access types. And then this will trigger many data, but it's not recommended to activate this all the time. But in the case of single cases, given point in time, I do suspect there might be funny things there. Yes, then you can activate it. And then the second question regarding the tables, event tables, for instance, those event tables you can have joins up to those new processes that are starting with all the new connections. I want that information to be retrieved. I want to get this information with the event table in the case of US query, or activating the auditing system. You can monitor this quite well. And some people did presented some posters about it and how to activate auditing systems. And I can send you the link. I can even show this to all of you, including this as part of my slides. Thank you. Excellent. Thank you.